So in this video, we're going to discuss what's called Gauss-Jordan elimination. And Gauss-Jordan elimination takes the row operators that you learned in the previous unit. It's going to take those row operators, and now we're going to solve matrices using those. And in order to do this, we're going to talk about what's called a reduced matrix. So a matrix is said to be in what we call reduced row echelon form. It's called reduced row echelon form, or simply just reduced form if these four conditions are met. And right now I'm formalizing them through this, but I'll show you examples in a few what that means. But the first one says, each row consisting entirely of zeros is below any row having at least one non-zero element. So if you look at the non-example here, this row of zeros needs to be below any row that doesn't have all zeros. And what that really just means is, if you notice the switch here, we did a row switch from row 2 to row 3. So we move row 2 down to row 3. We move row 2 down to row 3. And now notice this, the row of zeros is now below any row that doesn't have a zero leading it, which is this 1. And we're going to call that a pivot when we look at this. So if there's a number that's not a zero in the spot, it's called a pivot. The second says that the leftmost non-zero in each row is a 1. So if you look here, if you have a row of zeros, such as this row down here, and the leftmost these are all augmented matrices, by the way. These are all augmented. And you notice here, those have a 1 and a 0 above them. We'll look at row 2. Row 2 has all these zeros, but this is not a 1. We want that to be a 1. So to make it a 1, we're going to divide row 2 by 2. We're going to divide R2 by 2, and it'll give us a 1 in this spot. The third rule says that all the other elements in the column containing the leftmost one of a given row are zeros. So if we have a 1 in a row, we need all the other elements to be zeros. That's what this is saying. So the column containing the leftmost one in row 2 has a non-zero element above the 1. So you want basically zeros above 1s, and you want zeros below 1s. This is what we're going to get to in a second. And then the leftmost one in any row is to the right of the leftmost one in the row above. And again, this is going to help set us up where we're going to develop this thing called what we call the identity matrix. And the identity matrix, we're going to get to this. The identity matrix is saying that, let's take it 3 by 3. A 3 by 3's identity is this: 1, 0, 0, 0, 1, 0, and then 0, 0, 1. If you get a matrix like this, it's called the identity. Identities have 1s along the diagonals, along this diagonal part, and then there's zeros everywhere else. And an identity matrix is nice because if you augment an identity matrix with a column matrix, or with a constant matrix in our case, such as this will give the different values of the different solutions for each one of your elements. Remember, you have x1, x2, x3. So here I can tell you automatically that x1 equals 2, x2 equals -1, and x3 is equal to 3. So an identity matrix is nice because it gives us the solutions just by looking at it. And an identity occurs when you have 1s along the diagonals and zeros everywhere else. So the general rules we're going to follow for this then are going to be these right here. Here are our general rules for row reductions. We're going to try to make the leading element of the first row a 1. So when we start this, we always want to try to make the leading element a 1. We're going to try to get zeros underneath that element by adding and multiplying the first row to other rows. After getting zeros under the first one, we're going to try to get a 1 on the diagonal for the next row. So we want to put 1s, notice this, remember in our identity, first number is a 1. Everything underneath this 1 is a 0. Then we want to get a 1 in the diagonal next. Below is a 0, above it is 0. Then we want a 1 on the diagonal again. This final element should be a 1, and you want zeros above it. So you want 1s on the diagonal, 0 everywhere else. Continue this method until all rows having zeros with 1s are on the diagonal. So let's look at an example. This says, use the following row operators in order to get the matrix to reduce form. So what we're going to do is we're going to augment this matrix first. So this matrix augmented looks like this. Remember, we do our coefficients, so that's 3, 4, 1. And then we have 1, -2, 7. I'm going to give you the steps here to get this to an augment, to get to a row reduced matrix. And notice the first step here says switch row 1 and row 2. Well, I'm doing that because right here, I want to get this lead element up here to be a 1. And I see that I have a 1 right here. So my first step is to go 1, -2, 7, and then 3, 4, 1. So all I did was I did a row switch. R1 became R2. Row switch. Now, because I have a 1 right here, the next thing says to do -3R1 plus R2, replace R2. And I'm doing that because I have a 1 on the diagonal. I want to put a 0 underneath it. Well, how do I get this 3 to be a 0? I multiply the first row by -3 because that's going to turn this into a -3. And I'm going to add it to the second row. So the first row I'm not touching because it tells me to only work with R2. And so here I'll multiply R1 by -3R1, and I'm going to add that to R2, and that becomes the new R2. So -3 times 1 is a -3, plus 3 is 0. -3 times a -2 is a +6, plus 4 is a +10. -3 times 7 is a -21, plus 1, a -20. So I have this 0 underneath here where I want it. And now I'm going to move to the next element in this row, and I need that to be a 1 because I want a 1 on the diagonal again. So to get this to a 1, look what it says to do next. It says to divide that 10 by a 10. So I'm going to divide by 10, or really multiply by 1/10 in this process. So I multiply everything on row 2 by 1/10. So again, I'm not touching row 1. But I'm going to divide row 2 1/10 R2. So that's 0. 1/10 times 10 is just 1. 1/10 times a -20 is -2. Technically, this is reduced. We have this reduced. I want to get it to row reduced form, row reduced echelon form. But right now it's reduced because I know x2 here is equal to -2. I can back substitute for that and get the final answer I wanted to. But I'm going to keep going. The last thing says to, look, I need a 0 up here. I need the 0 right here. So how do I get that 0 up there? I'm going to multiply. I need to get this -2 to be I need to cancel it out with a +2. So I'm going to multiply row 2, the 1 down here, by a +2. And I'm going to add it to R1. So this time I'm replacing R1. I'm not going to touch R2. So R2 is 0, 1, -2. R1, I'm going to multiply by 2R2 plus R1. Well, 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus this -2 is going to give me a 0. And then 2 times a -2 is a -4. -4 plus 7 is a +3. So when I look at this now, I know that here is x1 and here is x2. So I can tell you that for this particular system, x1 is equal to 3 and x2 is equal to -2. So now let's do the exact same process. Look at example 2. And again, we're going to try to get 1s on the diagonals and 0s everywhere else. And so when we do this, the augmented matrix for this is 2, -4, 4, And then I have -6, 3, -12. So notice here, I don't have any ones leading. So I want to get a 1 in this first position. I always want the 1 to be sitting in this first position. So what this says to do is, your first step is to multiply by 1/2. That's like dividing by 2. So if I divide 2 by 2, I'm going to get that 1 sitting there. So 1/2 R1 becomes the new row 1. So 1/2 of 2 is 1. 1/2 of -4, -2. 1/2 of +4, +2. Bottom row, I haven't touched it, so I'm going to go -6, 3, -12. Now, my next step, again, is to get a 0 down here. So what I'm going to do is, when I look at this rule, it's telling me to multiply by 1/3. I don't want to do that quite yet. I want to get rid of all these. I'm going to write these actually out as I go through them. So the next thing I'm going to do is I'm trying to get that 0 sitting in this spot right here. So I'm not going to touch the top row. 1, -2, 2. But in order to make that a 0, in order to make this value a 0, right, or I can actually make it a 0, we're going to multiply everything on the bottom row by 6. So I have on the top row by 6. So I'm going to do 6 R1 plus R2. That'll put everything, that'll make that 0 sit there. So I have 6 times 1 is 6 plus a -6. 6 times 1 is 6 plus a -6 is 0. 6 times -2 is a -12 plus 3, -9. 6 times 2 is a +12 plus a -12 is 0. Right? So now I have the 0 sitting here. I want a 1 sitting next to it on the diagonal. So to get that 1 on the diagonal, my next step will be just divide everything by 9 on that bottom row. So I get 1, -2, 2. The bottom row, I'm going to divide by, or multiply by, -1/9. 0 times -1/9 is 0. -1/9 times -9 is a +1. And then -1/9 times 0 is 0. So there I have my 0, my 1's on the diagonal, 0's below it. And then the last step is I want to get a 0 up here. I want to get a 0 to sit here. So to get that 0 there, I'm going to multiply the bottom row by 2 and then add it to the first row. And the reason this works is because you're multiplying, when you start to get things to row reduced form, you're adding 0s and 1s. 0s won't change elements. 1s you can multiply by them to get them to look like the element. So that's why this works. So I'm going to multiply this top row by 2, R2, and I'm going to add it to R1. Notice when I multiply this 2 by the bottom row, that's a 0. And I'm adding it to that, so that's going to be +1, so that's just a 1. And then I do 2 times this 1. Well, that'll make this value a 2. Add it to that, that is a 0. And then 2 times 0 is 0. Add to that, that is just 2. So it looks like the solutions then, x1 and x2. x1 is equal to 2. x2 is equal to 0.